thermochemistry unit. And in our thermochemistry unit, we are going to take a topic and we're going to apply it to our thermochemistry studies. Typically, we call this the Mcat equation. And the Mcat equation has to do with something called specific heat. Your specific heat is how much energy you have to raise to any substance to raise 1 gram of it 1 degree Celsius. That should sound familiar because in the last video, we had something called a little c calorie. And a little c calorie has to do with water, and it's specifically water. And with your little c calorie, it's how much energy you have to add to 1 gram of water to raise it 1 degree Celsius. But every pure substance has this certain magical amount of energy that you have to add to it to raise 1 gram of it 1 degree Celsius. And we call that value the specific heat. So the specific heat of water is 4.184 joules. But then we also have the specific heat of iron, the specific heat of, aluminum, the specific heat of alcohol. All of these different things have their very own specific heats. So because we've already learned what a calorie is, the little c calorie, we already know that if you have 1 gram of that water, in order to raise it 1 degree Celsius, you need 4.184 joules of energy. So it is actually how many joules of energy per gram to raise it 1 degree Celsius. So all of this is the unit with specific heat, how many joules of energy to raise 1 gram of it 1 degree Celsius. So the specific heat of water is going to be very important to our math problems, and we're going to need to know that value. You don't actually need to know it because it is on your reference sheet. So when you're looking at your reference sheet, thermochemistry unit, that number is given to you. You just need to remember in the back of your brain, okay, specific heat of water, 4.184 joules, I can look it up. Any other specific heat, it's going to be given to you for my class. Now with your specific heat, like I said, everything has its very own value because everything, if it's a pure substance, takes a different amount of energy to raise 1 gram of it 1 degree Celsius. So when we look at specific heat, if we look at the specific heat of the concrete here versus the water, they're both, let's say it's, July. And with it being July, it is 3 o'clock in the afternoon on a sunny day. One group of people, this group of people, they are running a barefoot marathon. I don't know why they would do that in July, but I'm just making up stuff as I go. And then we have this little kid who is in the same park, but he's playing in a fountain in the water. We want to know which person has cooler feet. Is it going to be the people standing on the concrete or the person standing in the water? But they're both at the same time of day. They're both 3 o'clock in the afternoon, both of them on the same day in July. The kid is going to have much cooler feet than the people standing on the concrete here. If you've ever gone out in the summertime barefoot and went to go get your mail, you run out of your house, you hit the driveway, ouch, it hurts. That's because the concrete here has a much lower specific heat. It raises 1 degree Celsius with much less energy than the water. So water actually has a crazy high specific heat compared to other things, especially other covalent compounds, where it takes a lot of energy to raise it 1 degree Celsius. Where concrete or metal or something like that, it's going to heat up very quickly because it has such a low specific heat. It doesn't take as much energy to raise 1 gram of it 1 degree Celsius. So how we can actually calculate heat is through this equation, which we typically call the Mcat equation. So this is how you derive heat. You cannot measure heat. You have to calculate it. And your heat that is absorbed or released is going to be done through this equation that we have Q, which is heat, which is kind of strange, but it's Q is heat, is equal to MC delta T. So that's why it's called Mcat. Kind of looks like Mcat. Or if you're the guy that used to teach with me, he used to say, cat, and it was kind of creepy. But you have the Mcat equation, which is how you calculate how much heat is absorbed or released from a system. The M here is the mass. C is your specific heat. And then your delta T, remember a delta, we learned about that in the last unit. Delta means change in, so it's your change in temperature. and that's going to give you Q. Q is either going to be positive or Q is going to be negative, but Q is always measured in joules because it's heat, and it's how much heat gets absorbed or released, so positive or negative. It's all based off of the specific heat of that substance, so depending on the mass, what the temperature changes, and the specific heat, how much energy it takes to raise 1 gram of it 1 degree Celsius. Now with that delta, you're going to see 2 different temperatures. When you see your 2 different temperatures, it's going to say you're starting at 30 degrees Celsius, you're ending at 127 degrees Celsius, but you have to use the Mcat equation. With your 2 different temperatures, you're going to take your final minus your initial. So final, subtract off your initial. And that's the value that you're going to plug in for your delta T value. The constant will always be given to you unless that's specifically what you're solving for. But the constant values, you can always look them up. There are books and books of them, or internet. You can look them up there. But the water will not be given to you. You'll need to know that this specific heat of water is 4.184 joules per gram degree Celsius. It's on your reference sheet, so use that. So with your other specific heats, if it does not have anything about water, it will be given to you. You don't have to worry about memorizing anything except for water. So we've got some practice problems here to do. To do the practice problems, as always, we're going to jump over to our document camera. And this says the temperature of a 95.4 gram piece of copper increases from 25 degrees Celsius to 48 degrees Celsius when the copper absorbs 849 joules of heat. What is the specific heat of copper? So looking at my values, you have Q is equal to MC delta T. My delta T, I'm going to take my final minus my initial temperature to plug that in there. C is my specific heat, and then M is my mass. Mass is in grams, specific heat is joules per gram degree Celsius, and then my delta T is degrees Celsius. Q is joules. Joules is either absorbed or released. So in this one it says that it is increasing blah blah blah. It absorbs 849 joules of heat. All that means is that when I'm absorbing it, that value is positive. If it said that I'm releasing that amount of heat, I would have to put negative 849. So it says, what is the specific heat? So in this, I'm solving for C. So Q is equal to MC delta T. My Q is given, my joules of heat, I'm absorbing 849. So I'm going to put the plus just to remind me that that's plus. My mass is 95.4. My C is what I'm solving for. To get my delta T, I'm going to take my final minus my initial temperature. So in order to get that value, you're going to take 48 minus 25. I have 1 decimal place, 1 decimal place. So that means that when I plug this in, it needs to have 1 decimal place. So now all I'm going to do is I'm going to solve for C. To solve for C, I'm going to move this over, 95.4, and I'm going to move 23. And that's going to give me my specific heat. This has 3 sig figs, 3 sig figs, 3 sig figs. I need 3 sig figs in my answer. So 849 divided by, open parentheses, 95.4 times 23. My specific heat is 0.387 joules per gram degree Celsius. Specific heat has all of that unit there because it's how much heat is required to raise 1 gram of it 1 degree Celsius. So final answer is right there. The next problem, it says if 43 grams of water at 28 degrees Celsius absorbs, so positive, 1,605 joules of heat energy, what is the final temperature of the water? So I want final temperature. Q is equal to MC delta T. It gives me Q, 1605. It gives me M. It doesn't give me C, but I'm using water. So because I have water, I have 4.184 joules per gram degree Celsius. On this problem, it gives me my initial temperature, but I don't know my final. And I know delta T is equal to my final minus my initial temperature. So what I'm going to do first is solve for delta T. So to solve for delta T, I'm going to move this guy over, and I'm going to move this over. And that's going to give me my change in temperature overall. So 1605 divided by 43 times 4.184. 4 sig figs, 3, and 4. That means that I need 3 sig figs in my answer, so I got 8.92 degrees Celsius for my delta T. But I'm not done yet because it wants my final temperature. So I have 8.92 is equal to my final minus my initial temperature. So now all I have to do is solve for F. I need to get F all by itself. So I'm going to do the opposite of the sign. I'm going to add 28 here. I'm going to add 28 here. So 8.92 plus 28. Adding and subtracting for sig figs, I'm going to use the least amount of decimal places. It says 2 decimal places. This has 0 decimal places, so that means that my answer has to be a whole number with no decimal places. So my answer here, when I add those two values together, is 37 degrees Celsius for my final temperature. So I hope that this makes sense. If you need any questions or clarification, make sure that you contact me. Otherwise, I hope that you guys have a great